So hello, today we are learning the concept of matrices. So this is the subject in engineering. So let's start with basics so that it would be easier for you to solve problems. So to begin with, types of matrices. First is square matrix. Square matrix is nothing but where the rows as well as the columns should be same. That means if you have 2 rows, the columns also needs to be 2. 3 rows, the column needs to be 3. Example, 1, 2, 3, 4. If you have these as in a matrix, so you have 2 rows here. The horizontal represents the rows and the vertical elements represents the columns. Now, the next is column matrix. Column matrix is matrix which has one column and any number of rows. Any number of rows. So example can be 1, 2, 3, 4. So if you see here, it has only one column and it has 4 rows. So this is an example for column. So in the similar way, you have a row matrix. Row matrix is nothing but where you have one row and any number of columns. That means it should have only one row and n number of columns. So example, it can be something like this, where actually you have only one row but you have multiple columns. That means many columns. Now, the next is diagonal matrix. So what a diagonal matrix is? Diagonal matrix is a matrix where actually you will be having the diagonal elements, and apart from the diagonal elements, the other elements would be 0. So this is said to be a diagonal elements. The diagonal elements would be present. That means say for example, I have given A, B, C as an example. So other elements, if you say, it is all 0. So this is called as a diagonal matrix where only diagonal elements would be present and other elements would be absent. Nothing but it would be 0. Now the next matrix is unit matrix. So unit matrix is nothing but where actually you have the diagonal elements as 1. Other elements would be 0, but the diagonal elements would be 1. That is why it's called as unit matrix. Now, the next is symmetric matrix. So when it comes to the symmetric matrix, so what exactly this means? This means apart from the principal diagonal elements, the rest of the elements opposite would actually be the same. So example, let me take 0, 0. See, it is same. Now let me take another number. Let me give 5, 5. So this is same. Let me take another number 3, 3. Now what is happening? These elements, especially apart from the principal diagonal elements, the opposite elements, whatever you have, would be the same. That is called as symmetric matrix. So after symmetric, you have 0 matrix. It's also called as null matrix. So it is ZERO, 0 matrix or a null matrix, where actually all the elements present in the matrix is 0. The next would be equal matrix. So equal matrix, I can say that if the matrix is equal, so when I say A, B, C, D is a matrix and this is equal to 5, 6, 7, 8. So when I say this is a matrix, then I can write A is equal to 5, B is equal to 6, C is equal to 7, right? And D is equal to 8. So what's happening here? So only if the matrix is equal, I would be able to actually tell this particular variable A is equal to 5 and B is equal to 6. So understand, the order should be always same. This is 2 cross 2 matrix and this is also a 2 cross 2 matrix. So this is the actually types of matrices. So the next would be addition of the matrices and subtraction and multiplication. That's your next concept, which we'll be having it on the next video.